Imagine that the aircon in your office or your house is operating constantly without proper controlling of it. For example, during my internship, I observed that during the lunch hour, most employees or workers will just head off for their lunch without turning off the air conditioner. These so-called small actions or small issues will lead to adverse effects and be detrimental to our society. So how can we solve this issue, and how can we provide energy or save energy inside the building? A very good day to you sitting in front of the screen. My name is Lilo Yi, and today I will be presenting to you on the title which is called Investigation of Energy Saving Smart Sensor Controller for HVAC System. Project is prepared by Lilo Yi, Pang Chia, Sun Xiaoxing, and Wang Jifei, and supervised by Dr. Kang Cha Chao. This is what I'm going to present for today's presentations. So let's start with the introduction. As we all know that the COVID has outburst and stormed across the globe, the Prime Minister of Malaysia has asked all the citizens to stay put in their house. As a result, the electricity usage for households has increased drastically. So we don't want this to be happen. There will be some adverse effect if this issue is left unattended or without proper solutions to solve it, such as it will emit poisonable gases and it will cause climate change. So questions, how can we solve this and what can we do? The answer is very simple. It's by energy saving. And then how can we do that? And the answer is by the investigation of energy saving smart sensor controller for HVAC system. The objective of our capstone project can be divided into two, which are to prove the energy saving concept and to reduce the electrical consumption by the HVAC system. Secondly, is to provide a basic understanding of the function of the smart sensor controller for the HVAC system. So in our literature section, we have performed several in-depth literature regarding the general methods for saving energy for the HVAC system. As you can see from the slide, there are some reference with respect to their methods and finding. And one of them is called Adaptive Cooling System by Peng. So in Peng 2008, he and his team introduced a strategy to boost the performance of HVAC system to manage occupants' behavior in real time. And this strategy was used to control the cooling system of the office building under real-world conditions. And the outcome of this adaptive cooling system is the energy saving of 21% average. We also criticize that this adaptive cooling system is time-consuming, as it takes up 12 minutes of identification process, as well as it has limitation of memory and computing, and it is complicated algorithms to be embedded into the local controllers. Next, we also perform some literature on the existing sensors employed to save energy for the HVAC system, which, as you can see from the slide, there are 4 reference with respect to their method and their elaborations. So we also prepare the energy indicators for the measurement of the energy efficiency of the HVAC system in our literature. And there are 3, which are the seasonable energy efficiency ratio, SER, energy efficiency ratio, EER, and coefficient of performance, COP. We will be using them to justify our energy saving of the smart sensor controller. In our research method, we have purchased some hardware components to build our prototype, and there are 3 of them which are important, which are the IR sensor module, microcontroller Arduino Uno R3, and the 6-volt DC motor. So the IR sensor module will be used to detect the number of people or the number of mini-Troy figure passing through it. And the middle one, microcontroller Arduino Uno R3, will be used to perform and deliver the output to the 6-volt DC motor, so it can be controlled based on the number of mini toy figure detected by the IR sensor module. The last one is the 6-volt DC motor. So the total cost of our hardware component is 96.22 ringgit Malaysia, which is relatively cheap. Next, I will be going into the functionality of the smart sensor controller. As you can see from this flowchart, two IR sensor module, A and B, will be placed at the entrance and the exit of the room or the box. So the IR sensor A will detect and count the number of people entering the room. The IR sensor B, however, will detect the number and count the number of people leaving the room. The IR sensor will transmit the signal to the Arduino Uno, and the Arduino Uno will control the speed of the motor based on the number of people in the room. Next is the explanation of the Arduino code explanation. So this is a flowchart of it, and first, the counting of the number of people entering or leaving the room will be executed, following by the calculation of the total number of people in the room. So based on the number of people to decide the motor speed. Next is the procedure of building a smart sensor controller for HVAC system. As you can see, this is the block diagram of our smart sensor controller. Now, I will be showing you the video clip of the demonstration of our prototype of the smart sensor controller. Please enjoy it. In this video, capstone project for Group A will be demonstrated. This is the prototype of the smart sensor controller for the HVAC system. This is the mini fan blade, and this is an LCD display. Currently, the LCD displaying nobody in room, and fan is off. Therefore, there is no movement in the mini fan blade. On the right hand side of the prototype is an IR sensor module A, which represents the entrance for the mini toy figure. Conversely, on the left hand side is an IR sensor module B, representing the entrance and the exit for the mini toy figure. Now, if we allow one mini toy figure to pass through the IR sensor module A into the room, so one person in the room and the fan will start to spin. The spinning is according to the PWM value of the 128, which equivalent to 2.5 volt be delivered to the gate terminal of the MOSFET. If we allow the mini toy figure to pass through, 2, 3, accumulating 4, is still the same speed as what I have mentioned just now. Now, if I as more than 5, it will spin faster. Why? This is because now the PWM value has increased from 128 to 192, which equivalent to 3.8 volt to be delivered to the gate terminal of the MOSFET. So the mini fan spin at a medium speed. Now let's say if we allow the mini toy figure to continue pass through 7, 8, 9, 10, when it exits 10, 11, will become louder. Why? Because now the PWM value is the highest, which is 255, and it's equivalent to 5 volt be delivering to the gate terminal of the MOSFET. So the mini fan spinning at full blast. Now on the other side, if we allow the mini toy figure to pass through, as you can see, you can hear the sound getting lesser. So let me indicate here, if more mini toy figure is exiting the prototype by the IR sensor module B, the sound of the mini fan is decreasing, eventually until 0%. So nobody in the room, fan is off, and it turn off. Okay, next, I will be discussing about the results and discussion. So this is the design of the smart sensor controller with each proper label. And the left-hand side is the internal structure of our smart sensor controller. And the right-hand side is the external structure. So by using our smart sensor controller, we perform data tabulations with respect to the power generated with smart sensor controller and without the smart sensor, as you can see from the slide. The left-hand side is the total number of mini toy figure like 1, 2, 3, 0, 3, 7, and 11 with respect to their current and voltage obtained by using the digital wattmeter to measure it. So the power can be obtained from the formula as shown in the box, which is P equals to VI, and each respective power as shown in the table. So next, we also compute the bar chart of the number of toy figure versus efficiency. As you can see, 0, when the number of mini toy figures is 0, the efficiency energy is definitely 100%, following by the three numbers, which is 57.52%, 7 number 21.22%, and 11 1.77%. And the average efficiency of the energy saving by the smart sensor controller is 45.13%. We will be using this formula to calculate for our efficiency value. So next, we also perform a table of comparison for HVAC system with the smart sensor controller and without the smart sensor controller. So as you can see from the table, the first row is the hours per 30 days. And the second row is the average power consumption of the motor in the air conditioner, watt per hours. For the HVAC system without smart sensor controller, we compute the average power consumption is equivalent to 1 horsepower, which is 740.45 watts per hour. And by using our smart sensor controller, the average power consumption is 409.17 watt per hour. And the power consumption per 30 days, which is equivalent to the average power consumption multiplied by the hours per day, which is 720, we will obtain the 294.60 kilowatt per hour for the HVAC system with the smart sensor controller and 536.90 for the HVAC system without the smart sensor controller. Although cost saving, we also show the monthly charge from the domestic table, which is the domestic tariff table, TMB, and from there, our monthly charge for HVAC system with the smart sensor controller is 75.20, while the HVAC system without the smart sensor controller is 199.24, which is larger relatively than our expenses in buying the hardware component for our smart sensor controller. And the total saving is 24.04, and in terms of percentage is 62.26%. So, in conclusion, the operation of the smart sensor controller is in accordance to the number of people detected by the smart sensor controller, which means that more people passing through the IR sensor module, the mini fan will spin faster, and the total average energy saving efficiency by the implementation of the smart sensor controller is 45.13%, which is relatively larger than our original review, as shown in the slide just now, the adaptive cooling system, which is 21%, and this can reach that our objective is achieved. And the total cost saving of our implementation of the smart sensor controller for the HVAC system is 62.26%. So we should love our Earth by perform energy saving on it. Thank you very much.